Alright, so in this video we are going to start on the system in room 4, in which we hit a button and we have a gate at the other end that is blocking this entrance, and the button will start a timer that will also open the gate, and after a certain period of time has elapsed, the gate will close, blocking us off if we have not made it through in time. So to start this out, I need an actual gate here because currently there is nothing to block us from reaching this last room. So we don't actually have a mesh here that is going to work for the gate, so I'm going to create one. And I'm going to do this in the same way we created all of our prototype meshes here, and that is with the mesh modeling toolkit. So let's close the content browser for just a moment. And I'm going to model it right in place here so I know that I have the correct size. So I'm going to come up to the top where it says select. And I'm going to change, of course, to the modeling workspace here. Okay, so for this, I want it to be a gate that you can see through but not get through. So I'm going to start with a box here. I'm going to drag this box out, and I did some testing on this. So because I tested this a little bit off camera, I know that I want my width to be 25. I want my depth to be 25, and I want my height to be 800. And I chose 800 here, meaning 8 meters, because our wall units are half of that. So because we have this sort of dormered section, which is a little bit hard to see, this sort of dormered section that goes up, I want the gate to extend beyond that. So I just doubled it there. Okay, so I'm going, now that I have my first piece here, I'm just going to click to place it, and I'm going to hit complete. And that will give me this sort of single bar to start off with. So I'm just going to duplicate this across a few times. And I'm really just eyeballing this. Okay, so that looks pretty good. Looks good from that side. And I want to add a couple of crossbars going horizontally across it as well. So to do that, I'm going to hold Alt and duplicate this out and rotate it by 90. I'm going to move it up to approximately where I want it. And I'm lining up the pivot of this where I want it, because even though this is much too long, once the pivot is put in the correct place, it is easy to press R to go to your scaling tool and just scale it in. To about there. Again, these are placeholder meshes, so they do not have to be the most beautiful things that you've ever made. Okay. So I just press Alt and dragged up to duplicate that once more. So I have 2 crossbars going across, and that is going to compromise our gate. So now we have all these separate pieces that constitute our gate, but I want this to be a single static mesh object. So in order to do that, I'm going to merge these meshes together. So I'm going to click on one of them, and then I'm going to hold Shift and click to select every piece that I want to merge together. And once I have all those selected, I'm going to come over into the modeling sidebar here, and under the Create tab, next to where we have our duplicate, which we've used before, we also have something called Mesh Merge. And if you hover over it, you'll see that it says merge multiple meshes to create new objects. Well, that's exactly what we want. So let's click on that. Let's look at the options here. We have a write to here, which means basically, are we going to create a new reference here in our content browser, or do we want to overwrite one of the existing ones? Just for the sake of simplicity, let's leave it at new. We can name it here, so let's call it gate. We're going to leave the output type as from input, And we also want to delete the inputs. Remember, this deleting inputs here is going to work the exact same way it did for the mesh duplication. So once we have that set, we're just going to hit accept. And it's going to now merge these together into a single object, which you can tell by the highlight is now a single object. So let's open up our content drawer and look at the file itself. Here we have the gate right here. It has appended that random string. So I'm just going to go ahead and delete that. And now here you'll see we also have our boxes that we created when we were making the individual bars. So because we wrote to a new object, instead of replacing these files, it just has created a new one, but we don't need these individual pieces anymore. So I'm just going to delete them. Okay. Now, the last thing I want to do, and this is mostly a personal preference thing, is that it's a little bit hard to see this gate in this thumbnail icon. So I just want to rotate the preview image for the icon around so I can see this more clearly instead of at this like strange glancing angle. So the way I'm going to do this is by entering the thumbnail edit mode, which is a setting that you can do within this content browser window. So with the content browser open, I'm going to come over to this settings gear. I'm going to click on it, and I'm going to enable thumbnail edit mode. So what this has done is now I can come in on any of these images and click and drag to rotate them around so I get a better preview of my mesh. So this is kind of a good, especially if you have a lot of pieces, this is a good idea as it helps you see them a little bit more clearly. So once these are done and you have all your thumbnails oriented in the way that you want them, you can just hit this done editing here. That will exit the thumbnail editing mode. I'm just going to hit save all to save all these and get rid of those little asterisks. And there we go. We have a nice clear preview of all of our meshes. All right, so I do want to put a material on this. So I'm going to do that by opening the gate in the static mesh editor, which of course we get to just by double clicking. And I want to put one of my prototypes on this. It doesn't really matter what color you want. If you want to make a new color for it, you're more than welcome to do so. I'm just going to put the prototype grid gray onto this and click save. Alright, don't need these open for the moment. So there we go. We have modeled our gate here and we can move it around within the editor as a single object. Okay, so now that we have the actual physical gate, we need to script the blueprint in such a way that it can open and close at runtime in our game. So what we're going to do is we're going to come into the Blueprints tab, and I'm going to create a new blueprint class of an actor. I'm going to name it BP_gate. Let's double click to open this and add a static mesh component, which of course is going to be the gate static mesh that we just created. And I know that the scale is appropriate because I modeled it in the level. But what I do need to do before anything else is I want to delete this static mesh from the level, because if I add any code to this right now, well, nothing will happen because this is not actually our blueprint. This is the static mesh we created. So before we get all confused as to why our blueprints aren't working, let's delete the static mesh from the level and replace it with this BP_gate, which of course I just did by dragging it into the level. The same problem with rotation here, so I'm just going to fix that really quick and hit done. Okay, so we have our gate, we have our mesh. So now we need to think about how we want to accomplish this gate opening and closing, because at its most basic level, that's what we want it to do. We don't even want to worry about the button or the timer right now. We just want to be able to open and close our gate. So I'm going to pop over to the event graph, and let's get rid of all this stuff in here. And we're going to do this with a custom event. So I talked a little bit about custom events in a previous video, so if you need a refresher, go back and watch those. But for the most part, we're just going to right click, we're going to search for a custom event, and we're going to add a custom event. And I'm going to call this gate open underscore event. Okay, so what do we need to happen here? Well, we want to basically, whenever this gate opens, we want to raise this mesh up in the Z direction by, a certain number of units that we need to clear it. Well, we've already looked at how to, do a simple movement like that when we talked about our falling block blueprints. So essentially this is going to work the same way, and that is by using a timeline. So off of this gate open event, let's drag out and let's add a timeline. Let's call this gate open underscore timeline. And the reason I'm adding these suffixes here is because I believe that, you cannot have your timeline have the same name as your event because it will confuse Unreal. So that's why I'm, naming things with underscore event, underscore timeline, just to keep things really clear. Okay, so let's double click to open up this timeline and add a float track just as we did before. Now we want to change the height of the mesh in the Z direction, so let's name this Z height. Okay, so just as we did before, we're going to use the timeline to drive the location of the object in the world. So let's look at what our current world location is. And to do this, I'm just going to select the blueprint in the world. I'm going to open my details panel, and it says that my location, the Z value, is currently at 60. So that is the value I'm going to use here. Now, obviously, to make this more scalable, we would want to use a variable to drive this, but for the time being, because we're only going to be using the one in this level, we can just hard code this number in. So I'm going to right click and add a keyframe to my timeline. I'm going to set the time to 0, and I'm going to set the value to 60 because I want it to start where it already is in the world. Okay, so now we need to think about how fast we want this gate to open. I want it to open fairly quickly. So when we add another key to our float track here, I'm going to set the time to 0.75 for 3/4 of a second. Now we need to think about the value for this. So the way I'm going to determine the value is just by coming back into my level, opening up my details panel, and watching this value right here. We have a current value of 60. Let's slide it up to about where we think we want it to be. Let's say there. Yeah, there. So we have a value of 460. So we have a difference of about 400 centimeters or 4 meters. So for our second value, which is over here, this keyframe right here, and we're going to change the value from 60 to 460. And I'm going to click these just to frame this within my view. Remember, we need to reduce the length of the entire animation to the length of our keyframes here. So let's type in 0.75 and this length value up here to reduce that in. So the second thing, or I should say the last thing I'm going to do before I leave this timeline view is I'm going to change the shape of these lines. Right now this is just a linear line, which will give you sort of a hard stop, so to speak. It's a little difficult to describe. For the falling blocks, that's what we wanted because I wanted the movement to be very abrupt. But for the gate, I do want it to ease in and out a little. It will just make it feel a little bit more natural. So what I'm going to do is I'm going to highlight all the keyframes. So both of them there, I'm going to just click and drag to highlight them. I'm going to right click. And here where it says key interpolation, I'm going to change it from linear to auto. And you'll see that will just smooth this curve out, which is going to give us a little bit more of a natural looking animation, which in this case is what we want. So let's close out the timeline and return to the event graph. So now, of course, we need to tell it what to do with this z height value that we've given it, which is, of course, to set the world location of our static mesh. So just as we did with the blocks, I'm going to drag out a reference to the static mesh. And from that reference, I'm going to type out get world location. And from here, I'm going to split this pin by right-clicking on the vector return value and clicking split pin to get my values of x, y, and z separately. Now, remember that I'm doing this because I want to get the current values of the x and y from where it is in the world. Because if I accidentally reset these values to 0, this blueprint essentially will go flying off into space. So from the update, I'm going to drag out and type in set world location for the static mesh component. We don't really need both of these. It doesn't affect anything but the visual clarity here, but I'm just going to delete this just so I make it super clear that these things are being referenced to the same static mesh. I'm also going to split the vector input on the set world location node so that I can plug in my x to my x, my y to my y, and our z height to the new z location. Okay, so that is going to handle opening the actual animation of opening our gate, but right now we have no way of triggering this. So just for the purposes of debugging this, I'm going to make this happen when I hit a key on my keyboard, just as we have done in the past for various debugging purposes. So let's right click here and let's type in Z key and add a keyboard event for pressing the Z key. Now, off the Z key, all I really want it to do is to call this custom event. So I'm going to come off of the pressed node here and start typing in the name of my custom event, which is gate open event. Beautiful. Okay. So in order for this to work properly, there is one more thing we need to do, because if we try it right now, nothing will happen. And that is because this blueprint, this gate blueprint, is not currently receiving input because it's not a player. So there's a quick workaround for this. And all I have to do to allow basically this gate to be listening when I press a key, in order for this to happen, it needs to be able to listen to our input events. So to do that, we just need to enable input on this blueprint. So let's select the gate, BP_gate self from the component hierarchy. And over in the details panel, I'm just going to type in input. And that's going to filter my results here. This is the one I want to pay attention to. Auto receive input is disabled. That means that if I press the Z key, this event will not fire because input is disabled. So just for the time being, and again, remember, this is not for our actual gameplay. This is just for debugging purposes. We're going to change disabled to player 0, which if we recall, is our single player character. So let's hit compile and save. And because we've already replaced our static mesh here with the blueprint, if we hit play right now and come into the room so we can see what's happening, if we hit Z, the gate will open. Very nice. I'm going to move my player start over into this room for the purposes of being able to test a little bit more quickly. And let's move on, because right now, if we press Z, the gate will open, and if we press Z again, nothing happens. And this is because we have not told the gate to close in any way. So let's go ahead and add that functionality in now. Now, for our falling block obstacles, the block falling and the block rising were two separate timelines. And the reason I did it that way is because I wanted them to fall faster than they rose back up to the ceiling. However, in this case, I want the gate to close and to open at the same rate. So what I'm actually going to do is I'm just going to use this same timeline, and reverse it. So in order to do this properly, I'm actually going to change this play to play from start, because when you start going backwards and forwards on the timelines, you can get some hitching and some weird hiccups in your animation. And that is caused by basically, if it's starting over here, if you've reached the, it's no longer at the proper position. Because remember, this graph is describing the position of our gate on its z-axis in the world. Sorry if that wasn't exactly clear, but if it's not, leave it on play and not play from start, and you'll see what I mean. So let's go ahead, and instead of writing all this new code here, all we have to do is add a new custom event to close our gate. So let's right click anywhere in the graph and start typing in custom event and add it. And I'm going to call this one gate close _ event. So now, in order to get this to work, it's super simple. All we have to do is plug this one into the reverse from end. Okay, so currently we have this bound to our Z key, but we don't have any way to tell the gate to close again. So again, only for debugging purposes, I'm going to bind it to the C key. There's no special reason I picked C. It just doesn't have any function bound to it, so you can pick any key you like. And we're going to call the function here. So let's hit compile and save. And I'm just going to comment these out because it's a good habit to stay in. And let's test this out. So if we hit play, we hit Z to open, C to close, Z to open, C to close. Beautiful. That is exactly what we want. Well, at this stage, it is exactly what we want. We don't actually want this to be bound to keys, and we don't want our gate to receive input from our player 0, which means like we don't want to be able to trigger this with the key press. We just want to be able to trigger it when we step on a button. So before we forget, let's just go ahead and disable this in order to avoid any sort of bugs and errors down the line. But we know that this section of code works the way we want it to. So now all we need to do is to create the button and to trigger this event and this event from the button instead of from a key press. So I'm going to take a quick break in the recording here, and when we come back, we're going to work on the button side of this gate button system. All right, so we now have our gate system working at the far end of room 4. So let's move on to creating the button system that is going to eventually trigger that gate. So to get started with this, we need to create a button blueprint. So just as before, let's come into our blueprints folder under our content browser. And let's add a new blueprint class here of an actor. And let's call it BP_button to keep our naming conventions consistent across the board. Let's double click to open it. Now, just as everything else, we need a static mesh component in order to be able to see this in our game. So let's go ahead and add a static mesh component here. And click enter, or rename it if you prefer. And under our static mesh here, let's come down and I'm going to search for cylinder. And I'm just going to use a cylindrical static mesh here. Let's compile and save and drag our blueprint into our game so that we can get a good sense of the scale here. Now, this is actually probably pretty appropriate as far as width. I want it to be a button that we stand on, so it should be wide enough to do that, but obviously it is much too tall. So let's return to our BP button blueprint. Let's hit R to go into scale, or select it right here, and let's scale it down on the Z until it's more flat. And we can check this in our game and also check the placement. I actually want this to be a little bit thicker because when I stand on it, I want the button to move down. a little bit. So I need a little bit of thickness so it has some give to move down into the floor. So that looks about right. We can fine tune the placement by dropping our grid snapping either down to 5 or 1, depending on your needs for this item. And the last sort of pre-setup work that I'm going to do is I'm going to change the material here in the blueprint editor to be that same yellow material that we use for our health pickup. Okay, that looks good. Okay, so as I said before, what I want to happen is when I hit play and step over this button, I want it to, the button itself, the static mesh, to move down to indicate that we have activated it, and then of course that will trigger the gate to open. So let's just take this one step at a time, and let's just get the button movement scripted in first. So much like every other blueprint we have created so far, we're going to use a collision volume to detect when the player is on top of the button. So let's go ahead and add a sphere collision. And again, the reason I am using a sphere is because this is a round piece. So the sphere just better conforms to the shape of the mesh. So I'm going to come in here into sphere radius, and I'm just going to start sliding this value up until our sphere is approximately the same width at its widest point as our button mesh. Okay, so once we have our collision volume in here, we can start doing something with it. Of course, like just about every other blueprint in our game, our button needs to know about the player in order to detect if the player is overlapping it. So let's create our character reference in the exact same way that we have been doing up until this point. And yes, this does get very repetitive, but sometimes that's just how it goes. Okay, we have our player reference. I'm just going to comment it out so we can move this off to the side easily, and we're going to keep working here. Now, by this point, we should be very familiar with how to trigger events using a collision shape, or a collision volume, I should say, and we know how to check if it's the player. All right. As always, we just want to quickly check to see if this is working. And it is. Great. So we've looked at how to make simple object movements with an animation timeline before, and the button is really no different. So we're going to, off this true pin here, come in and add a new timeline. Let's see, let's call this button down timeline. All right, we're gonna use a float track the exact same way we have been. Let's call this the height. And in this one, instead of using its position in the world, I'm going to use what is called a relative location. So I just wanted to do this to introduce you to the concept and to make this button a little bit more versatile than some of these other pieces. Excuse me. So the relative location here refers to, if you come into your blueprint, into the component hierarchies, we have this thing called a default scene root. Now, this is just basically a point in space. It has an icon for the sake of our convenience and to be able to visualize it. But when we play the game, if we had nothing but the default scene root, it would not appear in game. And indeed, when we play the game, this sort of gear icon disappears. So this is just an editor icon so that we can see it if it has no other values. But basically, this default scene root just saves the location of your blueprint in the world. And in fact, if we highlight the default scene root and look at the details panel, it has no location value of its own. It only has scale. And that is because wherever the default scene root component is in the world is its location, and anything underneath the default scene root has these values because these values are relative to where this is. So this always has a relative location of 0, 0, 0. So I think this will make more sense if we compare it to the world location. So our world location for this and for our static mesh. So if you open the details panel, we can, by default, it will have the entire blueprint selected, but we actually can look at the properties of the individual components. This is our component hierarchy for this blueprint. So our static mesh has a relative location of 0, 0, 0 because it is placed exactly on top of our default scene root, which has the world location of, 4493, 3905. That is the world location. But relative to this world location, the static mesh component has a location of 0. So that's just a little bit of the difference between relative and world. So obviously a relative location has to be relative to something else. And in the case of blueprints, it is always going to be relative to whatever you have set as the root of your blueprint. Now, the root of your blueprint does not necessarily have to be a default scene root. It can be something like a static mesh. So if I were to drag and drop this over the default scene root, you'll see that the static mesh has replaced my default scene root as the root of the blueprint. And now I can no longer change its relative transform. Well, of course, that is not what we actually want. We want to keep our default scene root, but I just wanted to explain a little bit what is happening here with regards to relative transforms. Okay, so getting back to the actual scripting, we're going to come in here, we're going to change the relative location of the static mesh as compared to the default scene root. So what we're going to do to represent it visually is we're going to grab just this part and we're going to click it down when the button moves. So you see that it changes from a relative Z location of 0 to one of about -5. So let's make that happen with our timeline. So we're going to add a keyframe to this, change our time to 0, change our value to 0, or leave our value at 0, I should say. Click off and add another key by right-clicking. Now, the speed of this is up to you, again, largely. I'm going to set it to about 1/4 of a second by typing in 0.25. I don't want this to be a very slow fall. So, now keep in mind, I just tested this out in the viewport. I had a starting value of 0 and a finishing value of -5. So let's just put that as our value here in our timeline. Let's type in -5. Okay, let's frame up our selection so we can see our whole graph here. And of course, let's change the length of our animation to the length between the keyframes. I'm going to select everything here to highlight both keyframes. I'm going to right click and do auto, again, to make this animation a little bit more smooth. You can test the difference for yourself by testing out both methods, but having this set to auto will sort of have an ease in and an ease out effect, which is what I want in this case. Okay, so we are finished with the timeline. Let's close that out. And just like we did before, let's do something with this value for Z height. So we know that we want to work on the static mesh, and we know that we don't want to change the locations of the X and Y. So we're going to get its current location, but instead of getting the world location, we're going to type in get relative location. So instead of returning the location where it is in your level, it's going to return this value right here. Let's split this open so that we can control these values individually. And also off of the static mesh, we are going to, you guessed it, set relative location. We're going to split this as well so that we can plug x into x and y into y. And you may be wondering, well, if the relative location of x and y is 0, why do we need to do this? Again, you probably don't. You would probably be fine leaving this at 0, 0 by not connecting it. However, this is just another one of those fail-safe methods in case anything about these blueprint configurations changes as I continue to develop. It's a sort of covering my bases here. So let's connect the update to the set and the z height to the z. Let's hit compile and save. Okay, so let's look at what we have so far. Right now, when we begin overlapping with the collision volume, we're going to check if it's the player, and if it is, we're going to push the button down. So nothing other than our player can push down this button at the current time. So if you wanted to code something, you know, a sort of system similar to this, where maybe you have to set something heavy onto the button to keep it open, you would obviously have to change this portion right here where we determine only the player can make this happen. So just something to keep in mind if your design is deviating in that way from mine. So let's test it. Might be a little bit difficult to see, so I'm going to actually collapse some of these windows just to give us a little bit more screen real estate. So keep an eye here. It's going to be very subtle. Let's do it one more time. And in fact, it does move down by 5 centimeters. If you wanted to move down more, of course, all we'd have to do is change this value from something like -5 to, let's say, -10. Compile and save and test that out. And you can see it moves down significantly more. And I think that, in fact, looks a little bit better. So let's leave it at -10. Now, of course, the issue with this is that once it is down, it will stay down forever because we have not told it to come back up again. So we're going to add the button up behavior next. So just as I discussed for the gate blueprint, the button down and the button up action, I want to happen over the same time frame, meaning a quarter of a second. So I can basically just reuse this animation timeline here, as long as I code it to the proper checks here. So I'm going to select my sphere collision, and I'm going to add my on component end overlap underneath it. And we want to check that the player is no longer on the button. So let's just select all these and press Control and D to duplicate them. Let's connect these up the same way. So we're making the same check here, but we're checking for if the player has left the button. We are going to take the true and put it into the reverse. Okay, so let's test this out. And when we stand on it, it goes down. When we leave, it comes off. Awesome. That is exactly what we want in this case. So let's take a quick break in the recording right here. And when we come back, we're going to finally link up this button with this gate so that one will affect the other. I will see you in the next video. Okay, so we have our gate that opens and closes correctly when we trigger a custom event, and we have our button that goes down and up when the player moves over on top of it. So now we need to link the functionality of these two together to get the final result of pressing a button and it causing the gate to open. So let's start by opening our BP_button blueprint, which of course has our nice animation functionality here. I'm going to comment this out. Button /up. Just so we can group these together. Now, in order for this to work, we need to basically store some information. And the information that we need to store is our button currently being pressed or not? And if you recall from a few videos back, we already talked about how to store information in our blueprints in a meaningful way. And that is, of course, by using variables. So the type of information we need to store is a true or false value. We need to answer the question, is our button currently down? And the two possible outcomes of that are either true or false. So in order to store that, we need to store that variable as a Boolean type. So let's come into the variable side tab. Again, this is within the button blueprint. Come into the variable side tab and add a new variable. And let's call it B button down. The prefix B is for Boolean. And you'll see that the default variable type here is, of course, a Boolean, so we don't even need to change it. Okay, so we need to set this information to be true or false depending on what is going on in this code that we just wrote. So up until now, we've largely been changing the values either by using the default or by setting a float value with some basic arithmetic. But this is a Boolean value. So what we need to do is determine if it's up or down. So we know that when the player overlaps with the sphere collision component, and then it will play this timeline here, and that will put the button down. So let's drag out our B button down variable and set it to true once the player interacts with this sphere, or I should say overlaps with this sphere. So we're gonna just wedge this right in the middle. And when the player leaves our sphere, we know that the button down is going to be false. So once again, let's drag out and set it to false, which is denoted, of course, here by just leaving this checkbox blank. Okay, so we've wedged in our Boolean values here. Well, the reason I did this is so I can quickly determine by grabbing a reference to this variable what state of this we are currently in. I think this will make more sense as I use it. So let's just continue on. We just need to wedge these little values into here. So in order for our button and our gate to interact with each other, one needs to know about the other, because currently, if you will remember, blueprints are sort of a self-contained system, and unless we give it external references like we've done up here with our player reference, it doesn't know about any other blueprints in our scene. So we've looked at this a lot, creating this external reference here by getting this player character. Now this is a function that has been written by the team at Epic because this is a common thing that needs to be done. However, we do not have the luxury of just typing in something like get for our gate. We're going to need to set that manually, essentially. So we're going to create another reference here, but this time instead of pointing it at our player, we want to point it at our gate object. The object, of course, being the blueprint. So the way I'm going to go about this is I'm just going to come into the variables panel here, just like we did a second ago, and I'm going to click plus to create a new variable. I'm going to call this variable something like BP gate ref, something like that, to denote that this is a reference to the gate. So the last thing we need to do here, we obviously need to change the variable to the type of variable that this is, because we do not want this variable type to be the Boolean. We want it to be the type. The type of variable we want this to be is the blueprint for our gate. So the way I'm going to do this, and you can change variables down here, but you can also change them up here in the details panel. It's the exact same. So the way I'm going to do this is to type in my search bar, I'm just going to start searching for the name of the blueprint that I made for the gate, which of course was BP underscore gate. And you'll see it pops up right in here. Now we want this to be an object reference. So that will change the little icon here and the color to be an object reference type variable. Now, the next thing we need to do in order for this to work is we need to tell it what the gate is, essentially. So in the past, we've always set our variables in our blueprint editor by coming into the default value and compiling it. But if we did that here, if we compiled, we would get our dropdown. However, we cannot set a default value here. And that is, again, because there's no way within the blueprint for the button to know about the gate. So the way we need to be able to let these two blueprints see each other, essentially, is by making this variable public. So I'm going to do that by clicking this little closed eye icon right here. If I click it, it will open the eye. And that means that this variable is now public, which means it can be accessed by other blueprints. So not only can it be accessed by other blueprints, but it will also be visible in the editor details panel. So I've made this public here. So now if I come back into my level and I select my button, if I open my details panel, we now have this drop-down section called default, and it has our BP gate reference variable that I just created. Now, currently is set to none, just as it was within the editor. But because I am doing this from the level itself, from here, this blueprint is now able to look at everything that's in the level. And if it finds an object of this variable type, it will be available in this dropdown. So let's click on this, and you'll see right here, we have under our level, we have one instance of a BP underscore gate, which is of course the gate at the far end of the room. So let's set this reference right here. So now when I hit play, anything that I do in here, in the button blueprint event graph, anything that I do in here with this variable that I created, well, it will say, is there anything set right here? And if there is, this is what this variable is referencing. So I hope that was clear. So let's go on and use this in a practical example. So what we need to think about what we actually want to do with this. So we have our gate reference here. So essentially now our button knows about our gate. And let's just open the gate blueprint and remind ourselves what kind of code we have in here. Well, this is the only thing we currently have in our gate. We have a way to open the gate and to close it by triggering a custom event. So since we already have this set up and our button knows about our gate, all we need to do is use this gate reference to trigger these events. So let's just think a little bit about when we want to trigger these events. Okay, so we have our button down, and this is all occurring while the button is moving, but we also have this finished node right here. So once the button reaches its final location, anything that is written off of this node will happen. So that is where we want to place our gate opening and closing. So because we are using this timeline for both opening and closing, we need to know when we finish it, is it finished playing forward or finished playing in reverse? And this is why I set up this Boolean for the button down variable. So if we step on our button right now and it runs through forwards, it's going to spit out anything that happens here in reverse. However, if we leave it and it runs backwards, well, when it finishes, it's still going to do whatever comes off of here. So let me just quickly demonstrate this by putting in a print string. It just says hello. It doesn't matter what it says, but I just want to demonstrate why these Boolean values are necessary, because so far we have set them, but we haven't used them. So the reason I did this, to demonstrate it, we move our button down and it triggers the finished hello print string. We move our button up and it triggers the hello finished print string. So right now, anything that we put here will happen regardless of whether or not we're entering the collision volume or exiting it. But we want different things to happen based on if the button is going down versus going up. So all of that is a very long-winded way of saying we need to branch off of this finished node right here. We need to create a branch, and we just need to evaluate whether or not the button is up or down. I'm just going to double click to add a reroute node to make this a little more a bit clear. So if the button is down, meaning it's true, we want to open the gate. If the button is not down, meaning it's false, we want to close it. So let's start with the true. So we already have our reference here, or you can pull a new one in. All we need to do is call the gate open event. Set that up here, compile, save. And now if we play, in theory, boom, when we hit our button, the gate will open. Now, currently, we do not have anything telling it to close. But before we do that, I do want to address a possible serious bug that can occur with our current setup. So we have our current setup set up the way it is, obviously. Now, if this value becomes none, or you forget to set it, or for whatever reason, this value is not set, this system will break entirely, because when it looks at this variable, it won't know what you're asking it to look at. So if I set that to none by clearing it, nothing happens. And then we get this big, ugly, scary error message saying that the variable you set here has no value, basically. So obviously we need to set it here, but in order to avoid these errors that could possibly break your game, the other thing we need to do is kind of throw in an error handling node right here. So to do that, I'm actually going to drag out a reference from our gate. I'm going to type in the word is valid. And I'm going to use this one with the question mark icon next to it. So from true, I'm going to drag it into the execute pin. And from is valid, I'm going to drag it into the gate open event. So all this is doing is basically making it so your game will not crash entirely. If there is no reference set here, basically it just errors out of this function and nothing will happen. So it still won't work properly without that reference being set, but it will prevent your game or your engine from crashing altogether. So this is valid. It's very important when you are setting references in this manner. So if I were to come in here, clear this value so it's not set, you can see it still does not work, but when we hit exit, we don't get the big scary error message there. Okay, so let's reset that. And we now need, obviously, to close the gate when we leave. So we've already set up handling for evaluating when our player leaves the collision volume, basically steps off the button. So, and that of course is coming off of this false node. Is button down is false. We want to close the gate. Well, first we need to check to see if the gate reference is valid. And if it is, we need to close the gate. Now you'll notice that when I dragged off the execution pin and started searching, the close gate event was not available. And that, of course, is because Unreal doesn't know where it's supposed to be looking, so it's just looking within itself. Because this is an external reference to a different blueprint, when I drag out here and search gate close, Well, it's also looking within this blueprint as well as itself, and it does find a search result for that. So just keep in mind that you do have to drag off of this reference in order to access these functions that are written within it. So let's compile and save and test to see what we have going on. Step on, it opens. Step off, it closes. Great. So that is more or less what we want, but obviously when we play, we're going to need to hit this button and then jump across to the other side. So we need to set up a timer system here. And we're going to use a pretty rudimentary timer system. Because this is a very simple timer system, we can just use that same delay node that we have used up until this point. So we don't really want a delay when it opens, but we do want a delay before it closes. So off of this is valid. I'm just going to drag off and type in delay. Now, as far as how long this needs to be open, you will probably need to play test that to determine what the appropriate amount of time to leave the player is. Let's just start with, let's say 10 seconds. And test that to see if it works. Okay, let's hit play. We hit our button here, and now we have 10 seconds to jump across, and we make it with plenty of time to spare, it seems. There we go, and it is still closing, so we know that the 10 seconds is working. So how difficult you want this to be is entirely up to you. You can make this obviously more difficult by reducing the number of seconds in the delay. I'm just going to leave it at 10 for the time being in the sake of this video. Now, we talked a little bit already about public variables when we went through this gate reference situation right here, but we can use public variables in all sorts of ways, not just to point to other objects. We can use them to expose certain values, such as how long should this delay be in the editor itself. So I'll show you what I mean by that. Let's drag off this, or I'm sorry, let's right click on this and say promote to variable. Now this will give us a new variable with the default name of the input, and it will default to the correct variable type. The default name is duration. I'm going to just be a little bit more descriptive than that and say delay time. So now we have this variable saved as a float value, which of course is in seconds, the duration of this delay. However, it has saved our input value right here, and that's all fine and good. And we can change it by, changing this default value. However, we can also deviate from this default value by exposing this and making it public by clicking this eye icon. So now if we compile and save it, if we return to the level and we click on this button, now in our default dropdown underneath our gate reference, we also have something called delay time. So what is functionally the purpose of this? Well, it allows us to instance this whole button system in a way that makes it really flexible. So if we had multiple rooms in our level or multiple levels that used a similar system, we, instead of writing a new button for it, we can just reuse this button. So all we would have to do if we needed a second gate system, well, we could, let me dock this for a moment. We could drag out a gate. Let's just put it here for the sake of demonstration. And we could drag out another button. And I want this button to point to this gate instead of this one, right? So this gate is called BP Gate 2, which has, of course, a different name than just the BP gate. It just gives it a number to differentiate between the two. So I want this one to point to this one. So let's set that reference here. And let's say I only want this one to have a delay of 1 second. So now if I hit play, I can open this one. This one still works the way it should. It will give you a delay of 10 seconds. We can sit there and count it. And now this one gives us a delay of 1 second. So it allows you to have a lot of flexibility and scale these systems up really well if you are appropriately using variables that are public. So just something to keep in mind. Of course, for this level, we are keeping it very simple. We're only going to have the one, but if you did want to scale this project out farther, that is a way that you can reuse these blueprints. And you can use these variables in any number of ways. Like for instance, the falling block here. Well, you could set up a system where you have maybe a different delay on the time it takes between the player triggering this and the block falling, or a different speed, or you could even have something like the fire particle system that shoots out of these little fire spurts. You could have that set as a variable. So maybe one of these shoots out a normal fire, but one of them shoots out a blue fire or a green fire, or maybe not even a fire altogether, maybe something else. So keep that in mind, that variables and the use of public variables in blueprints are very, very flexible system and allow you to expand the functionality without having to rewrite a bunch of code. So it makes it very quick and very easy. So that is it. I think 10 seconds is about appropriate. We can always change it later. We have the public variable set up in such a way that it is very easy for us to playtest and change this value at any point. So that is going to wrap up the system for the timed button and gate. And in the last section of our scripting for our prototyping, we are going to come into this end room, and we want to make a sort of reward system at the end that lets our player know that this is the end of the level. So I will see you when we return.